All right, guys, this is going to be our fourth lesson here about rational exponents. Before we get started, I just want to commend you guys for the work that you have done. I know this is a difficult situation that we're all going through right now. So just the work that you guys are doing, I'm very appreciative of that. And I would just like to continue to praise you guys for the changes that we're going through. And just I'm just want to say I'm proud of what everything you guys have done. And so let's go ahead and hop into our lesson for today. It's going to be rational exponents here. Now, there will be some key things we need to know before we get started. You can write a radical expression in an equivalent form using a fractional or a rational exponent instead of a radical sign. So in general, if we have the nth root of x, that also equals 1 over x to the n. So whatever type of radical we have, whether it's a square root, a cube root, a fourth root, or what, it could be more than that also. Whatever type of radical that is, that's the power that it's going to end up being as well for any positive integer n. Like the radical form, the exponent form indicates the principal root. So like we said before, the radical of 36 can also be written as 36 to the power of 1 over 2. All right. The cube root of 36 would then be 36 to the power of 1 over 3. So again, whatever number is in front of that radical there, that's going to go on the bottom part of our fraction. Okay. The whatever number on the inside of the radical is raised to, that'll go on the top part. So again, if we don't see 1, that's going to just end up being 1 because 36 to the first power is still just going to be 36. Okay. All right, so example 1 here. What is the simplified form of each expression here? So our first step, okay, so this one we are going to go from our rational part here, which is our fractional exponents, and we're going to change that back into our radicals here. So again, knowing that our denominator there and our exponent is 3, that means we're going to have a cube root here. So it's going to end up being the cube root of 216. So again, if you don't have that list, you may want to write that list out. Your first 10 perfect squares, perfect cubes, and perfect fourths. That may be a good list for you to have for today's lesson. Luckily for us, the cube root of 216 is a perfect square, so this answer does simplify down to 6. Okay, so that would be our final answer there. All right, second example here. So we're going to go ahead and rewrite these into radical form here. So 7 to the 1/2 power would just equal the square root of 7. And 7 to the 1/2 power would also be the square root of 7. Now I can multiply these radicals here. So radical 7 times radical 7 would give me radical 49, which is a perfect square. So that should reduce down to 7. All right. And then we have our last example here, 5 to the 1/4 times 125 to the 1/4. So in radical form, that should be the fourth root of 5 times the fourth root of 125. So since these radicals are the same, I can multiply these two radicals together. So that's the case. I should have the fourth root of 5 times 125 is 625. And if you go through your perfect fourths, 625 is a perfect fourth. So again, that should equal when reduced to 5. Again, make sure you have that list, guys, because this is going to be kind of big for us as we move forward today. All right. So another key thing we need to also make sure we're aware of for rational exponents, if the nth root of a is a real number, m is an integer, and m over n is in lowest terms, then we can look at this as one of two ways. So we already know that going from a rational where our exponent is a fraction into a radical. Now, also understand, this is kind of the key point here, is that this can be written in two ways. So again, if we have an exponent on the inside, it can be written as a parentheses with an exponent on the outside. So we're probably going to see a lot of that today. Just make sure you understand that you can write it both ways and they equal the same thing. Okay. Just a key thing you have to understand though, m cannot be if m is negative, a cannot be 0 because it's not going to work out for us. It's going to be an error whenever you type that in. Okay. All right. So knowing that now, converting between exponential and radical forms here. So we've kind of started this before. We're going to rewrite these into radical form in this one here, and then we'll show you the reverse of that going from radical into exponential. Okay, so we're going from exponential to radical. So my first step is to rewrite that. So that'd be, since that bottom number is 7, that means we're going to have the 7th root here, and then it's going to be x, and then I'm going to write it as we kind of saw in that big form there. So I'm going to put parentheses around this to the 3rd power. So that would be x to the power of 3/7. Okay. For that y, if we have a decimal, so we have y to the negative 3.5. Anytime they give you a decimal, convert that decimal into a fraction. Again, your calculators that you have should convert that. Again, I do believe it's math, and then it should be, I don't remember the numbers, but I think it's like number and then like fraction, I want to say, convert to fraction or something like that. But that does change into y to the negative 7/2. Now, anytime we have a negative exponent, this is kind of key for us here. Anytime we have a negative exponent, we're going to rewrite this. So to make that a positive exponent, it's going to end up becoming, we're going to flip it. So essentially, to make that positive, that will go from the top of our fraction to the bottom. So essentially, with nothing left on top, it's going to be 1 on top, and it'll be y to the 7/2. Now that is in simplified form here, now we can rewrite this in radical form. And this in radical form would be 1 over the square root of y to the 7th. Now, again, be careful here. We're looking to simplify. So again, since we're looking to simplify, the biggest multiple of 2 that goes into 7 without going over would be 6. So I can rewrite this as 1 over the square root of y to the 6th times the square root of y, because 6 plus 1 gives me 7. Okay, so from there, the square root of y to the 6th ends up being y to the 3rd. So we have 1 over y to the 3rd radical y. Now, also be aware, we cannot have radicals in the bottom part of our fraction here, so we do have to rationalize it like we learned last time. So luckily here, we're just multiplying times the radical. So at the top and the bottom, we multiply by radical y. Luckily for us, those two radicals just end up becoming a positive y there. So y to the 3rd times y will then just give me y to the 4th. So my final answer here is radical y over y to the 4th. Okay, again, we cannot leave radical in the bottom part of our fraction here, so make sure you're careful about that, guys. All right. Example 2. Now this one we are going from radical form here back into exponential form here. All right. So if we can simplify, we want to look to simplify first. From here. So if that's the case, actually I take it back. All we're doing is just going to exponential. We're not looking to simplify here. So if that's the case from here, we should end up left with. So again, we're looking at the radical for this first one here, the square root of a to the 5th. So that would end up being a 2 for our denominator. So it's going to be a to the power of 5/2. Again, the 2 goes on the bottom because that's what the radical is. And whatever that power is going to end up being the numerator every time for us. So again, understand these are both ways that we can write this. Whatever the radical number is, that's going to be the denominator. So on this one here, for the second one, that's going to be b. And again, the denominator should be 5. And the numerator is going to be 3. So make sure both of those can be written the same way. Just know the difference between them and how you can write them from radical form into exponential form. That's all they're looking for there. Okay. Example 3, using rational exponents here. So Kepler's third law of orbital motion shows how you can approximate the period P in Earth years it takes a planet to complete one orbit of the sun. Use the function of P equals d to the power of 3/2, where d is the distance from the planet to the sun in astronomical units, or miles. Okay, so it looks like I forgot to get the picture on here for some reason. I don't know what happened to it. So essentially, the picture was supposed to have, I don't know what happened to the picture. All right. But that picture was supposed to show the distance from the sun to the moon. And it told us that distance was, I got it right here. Let me see. That distance was 1.52. There was a picture that was supposed to be on there showing you that, right? The distance from the sun to Mars there. Okay, so it says how many years does it Earth years does it take Mars to orbit the sun? So essentially, again, the picture's supposed to be there, and if we had the picture, you would see that that's where that 1.52 came from. I just forgot to post the picture on that. That's my fault, guys. All right, but all we're doing here is knowing this information right here. We're going to plug it into our formula. If that's the case, here's our formula: P equals D 3 over 2. Knowing that D is 1.52, then it's going to be P equals 1.52 to the power of 3 over 2. And again, all we have to do, guys, is just type that into our calculator and simplify it here. So P should come out to be right around 1.87. That's my fault, guys. I'll do better next time. My apologies. Okay. All right. So this will probably be a good reference for you guys right here. But these are some properties of rational exponents here. So if you ever get stuck, there we go. If you ever get stuck on any of the properties, this is a good reference to refer back to in this video here. So make sure you understand to use this here as a help for us as we move forward. So again, all of our properties of rational exponents, if you ever get stuck on any of the problems, come back and use this as an example here. Okay, because again, this is a really good tool for you to look back on in this video. All right, so with that being said, example 4, combining radical expressions. All right, so whenever we're combining these, our first step is going to end up being to write our radicals into exponential form. All right, so that's what I'm going to do first. I'm going to write these in exponential form. So that's going to look like this. It should be x to the 3/4 power over x to the 2/8. Now, again, since we have the same variable on top and bottom here, then we're just going to end up subtracting my two exponents here. So I can rewrite this as x to the power of 3/4 minus 2/8. Now, unfortunately, we cannot subtract or add fractions with different denominators. So I'm going to look to simplify that fraction of 2/8. That simplifies down to 1/4. So it should be x to the 3/4 minus 1/4. So now with them having the same denominator, I can actually simplify this here. So that 3/4 minus 1/4 ends up being 2/4. 2/4. And again, 2/4 reduces down to 1/2. All right, so then x to the 1/2 can be rewritten as the square root of x. So that is written in simplest form. Okay. All right, example 5, simplifying numbers with rational exponents here. So again, if you ever see a decimal, your first step is to make sure that you are converting that to a fraction. So again, -2/5 written as a fraction. Again, you can type this into your calculator, all right? But that would be 16 to the -5 over 2. Okay, remember that is our exponent there. So we have a negative exponent. We cannot have negative exponents. So again, if it helps you out, put it over 1, and we're going to rewrite this as 1 over 16 to the 5 over 2. Now let's write it in radical form here. So if that's the case, it's going to end up being 1 over the square root of 16 all to the power of 5. Luckily for us, the square root of 16 is a perfect square. So the square root of 16 ends up being 4. So we have 4 to the 5th power. And that actually is a pretty big number there. 4 to the 5th power ends up being 1 over 1,024. 1024. Okay. We have another example here. So on this one here, my exponent here is not negative. It's already positive. So we don't have to rewrite this. And it's not a decimal, so we're already good there. So since that's all good, we're going to go ahead and rewrite this in radical form. So again, looking at our denominator here, that means we're going to have a 5th root here. So it's going to be the 5th root of -32, all of that to the 4th power. Now, You have to be careful here. So with negative radicals, you have to make sure that your radical is an odd radical. And what I mean by that is it a third? Is it a fifth? Is it a cube root, fifth root, seventh root, ninth root? All those odd roots can have negative exponents, or not negative radicals. Okay. Luckily for her, we have an odd root. That's a fifth root there. Okay, so then let's check. If I type this into my calculator, the fifth root of negative 32, this actually comes out perfectly because that is a perfect fifth. Again, you can always check yourself by typing into your calculator. This one works out perfectly because the fifth root of negative 32 ends up being negative 2 to the fourth power. So all I did was just simplify the inside of those parentheses first before implementing that power of 4. So I have negative 2 to the fourth power, which does end up giving me 16. All right. We'll move on here. Example 6. We're almost done, guys. Writing expressions in simplest form. So again, there will be variables as well. We have to be careful with these. First step, again, if you have negative exponents, make sure you fix those first before you do anything else. But first step for here, we're going to end up distributing that into both terms. So I'm going to distribute this 2/3 into both terms. So the way it's going to look is we're going to have negative 8 to the power of 2/3. We're going to have x to the power of 2/3. I'm going to rewrite this this radical of xy here, okay? So again, if I wrote that in exponential form, that would end up being, I'm going to put this in parentheses here, times xy, because that's what's on the inside there. And that radical of xy would be to the power of 1/2. Because again, the denominator would be 2, which means if I rewrote that as a radical, it'd be radical 2, and it's to a power of 1 there. Now, this entire thing, though, this radical will also be raised to the power of 2/3. Okay? So we're going to take this piece by piece and start to simplify here. All right. So we're going to end up having the cube root of negative 8, all of that squared. We're going to have the cube root of x and all of that squared. All right. And if I have an exponent raised to an exponent, again, if you go back to that properties table that I showed you earlier, an exponent raised to an exponent, you multiply your exponents there. So I'm going to multiply these out first. So 1/2 times 2/3. So 1 times 2 is 2. 2 times 3 is 6. So we have 2/6, which reduces down to 1/3. So when I multiply these, that's going to give me 1/3. So if I rewrite that, that's going to give me the third root times the third root of xy. So again, all of these have the same radical here. So again, I'm going to go ahead and make this one big radical since everything here is the same. So I have, or I can actually look to simplify some of this already. So from here, the cube root of negative 8. Negative 8 is a perfect cube. So again, the cube root of negative 8 ends up being negative 2. And that's going to end up being squared. All I did was I just simplified the cube root of negative 8 right there. This cannot be simplified. Okay, so that's going to end up being the cube root of x squared times xy. So that's going to give me the cube root of x cubed y. All I did was I just combined everything there, guys. So I just combined all of that together. So from here, negative 2 squared gives me 4. And the cube root of x cubed will give me x. So that means we're left here with the cube root of y on the inside. All right, last example. Last example here, guys. Example 6. All right, so first step, I'm going to distribute that negative 3/4 into all of my exponent, or into all of my terms there. So if that's the case, I'm going to have 16 to the negative 3/4, and then I'm going to have y to the 8th times 8 to to the negative 3/4. Negative 8, sorry. Remember, so since I have a whole number there, I'm going to put it over 1, because if I have an exponent raised to another exponent there, then again, those are going to multiply. So if I multiply these two fractions there, negative 8 times negative 3 would give me a positive 24. And 1 times 4 is 4, so that's going to reduce down to positive 6. So I have 16. So since that has a negative exponent here, I'm going to go and move it to the bottom. So I have y to the 6th over 16 to the negative, or sorry, not negative, 3 over 4. Rewrite that in radical form. So we have the 4th root, or y to the 6th on top. We have the 4th root of 16, all of that 16, all of that to the 3rd power. 16 is a perfect 4th for us, so I can simplify that first. So I'm going to have y to the 6th over the 4th root of 16 is 2, all to the 3rd power. And 2 to the 3rd power does equal 8. So y to the 6th over 8 would be our final answer. Okay, so make sure you're simplifying all your steps there. All right, guys. So that's going to be the end of our notes. Your homework, since this is Tuesday, your homework will be due tomorrow at 11:59 p.m. Virtual office hours, the same time as always, 1 p.m. to 2 p.m. Again, it's not mandatory. It's just like tutorials. It's for your benefit, guys. So again, make sure you are showing up. If you have questions, now, if it's kind of urgent, you need to talk to me at that point, please feel free to email me. I'll try to get back to you as quick as I can. Other than that, guys, just keep up the great work. I'm really proud of the work you guys are doing. So if you have any questions or concerns for me, just please get in touch with me. Other than that, guys, keep up the hard work. All right, guys, take it easy.